ESA stands for European Space Agency. It was established in 1975 in Paris, France. The Western European nations had decided to form two correlated agencies to launch European space endeavors. ELDO, which stood for European Launch Development Organizations, was in charge of developing the launching system, and ESOR, which stood for European Space Research Organization, was in charge of the research. They joined together in 1975 to form the ESA. The ESA has 10 founding and active states: Belgium, Denmark, France, Germany, Italy, Netherlands, Spain, Sweden, Switzerland, and the United Kingdom. The headquarters is located at Paris, Île-de-France, France. The mission control that monitors every space flight is located at Darmstadt, Germany. The ESA fosters many space endeavors. Their missions have a high success rate. Out of the many that have been initiated, we think that the following three stand out the most: the Ariane launch rockets, the CRO exoplanetary research satellite, and the famous Rosetta mission.
The Ariane launch system are a series of expendable launch vehicles made to carry payloads such as satellites, space shuttles, and telescopes into space. Developed in 1973, just before the formation of ESA. Many versions of this launch system were built, with models ranging from 1 to 4. All of them posed drawbacks until the Ariane 5 and Ariane 6 were developed. They serve almost all of ESA's space missions, and are the successor of its previous model of launch vehicles, called the Europas, which proved to be a failure. They have provided a reliable launch success rate of 94%, and are now being used regularly by all of the other major space agencies, including NASA, the JAXA, and the RFSA.
COROT stands for Convection, Rotation, and Planetary Transit. This project was created by the ESA and other countries. It's a satellite with two main occupations in space: to observe and record stellar oscillations and search for signs of exoplanets. The fundamental research point in the field of astroseismology. This is the study of a pulsating star's internal body and movements, also known as oscillations. Oscillations is a continuous vibration of an object relative to its equilibrium. In stellar matters, it describes a star's outer field to its central field. The COROT 4 has powerful CCD, charge-coupled devices, cameras, which track a star's motion with a microscopic precision. This study made by the COROT on stellar oscillations provides important data to calculate a star's radius and mass even more accurately than it calculated by its brightness. The COROT CCD cameras can also search for extrasolar planets, which are planets far away from our solar system that orbit a star similar to our Sun. The cameras observe a star for long periods of time. When a dip in the star's brightness is observed, it means that a planet has passed it. It then tracks and records any data about the planet. So far, it has recorded around 27 exoplanets. COROT 7b is the first rocky planet discovered by COROT. It was later dubbed Super Earth due to a density similar to our Earth. It orbits a star at a very close distance, thus it takes only 20.5 hours to complete an orbit. Its revolution position is synchronous to the rotation of the star, so one side is always facing its star. The COROT was a huge success and leap in astronomical science. On November 2nd, 2012, the COROT suffered a major computer failure which made it impossible to relay data back to the Earth. On June 24, 2013, the COROT was brought down into low Earth orbit to burn down. It provided valuable information about stellar oscillations and exoplanets.
The Rosetta space probe was launched by the ESA. It was dubbed the Comet Chaser due to its unique job. Its job is to track, follow, and collect data of Comet 67P Churyumov-Gerasimenko. 67P is a moderately sized comet that orbits in the asteroid belt. It was launched on March 2, 2004 on Ariane 5 launching rocket. In late 2003, a 3D image of the comet was programmed by the ESA scientists. The Rosetta space probe carried a landing rover called Philae. Philae was to land on a comet, dig into it using its drill, collect pictures of the surrounding area, and take ground samples. And while Philae did all this, the Rosetta space probe orbited the comet and collected aerial pictures. Here is the timeline of the Rosetta space mission. Early 2003, the final planning and culminative construction was done. March 2nd, 2004, the Rosetta space probe was successfully launched from Cairo, French Guiana. March 4th, 2005, Rosetta completed its first gravitational swing around the Earth. The instruments on board were refetched and calibrated using Earth's magnetic field. February 25th, 2007, Rosetta completed its Mars swing-by and used its gravitational force to alter its direction for a second flyby on Earth. November 8, 2007, it was misidentified as an asteroid by an astronomer. November 13, 2009, Rosetta completed its third and final swing by over Earth. June 8, 2011, as the probe was on course towards 67P, all instruments was put into travel hibernation. January 20, 2014, a planned timer interrupted the hibernation phase. Rosetta was back online with the ESA's control center in Darmstadt, Germany. May to September, Rosetta approaches its rendezvous in an orbit around 67P. Upon entering a successful orbit, it conducts various searches and takes aerial photos of 67P. It also begins mapping the comet. Its final 3D simulation of the comet is sent back to the ESA. It is more accurate than previous models. November 12, 2014. Helios successfully landed on the comet. Its recorded landing was watched live and globally. It collects samples on the ground and takes lots of pictures. November 2014 to December 2015. Rosetta follows 67P around the Sun until its comet approaches to the Sun's perihelion. December 2015 is the end of the mission.
The ESA has proven to be at the forefront of man's astronomical endeavors. They are leading in technology, spacecraft, and have an indispensable group of scientists. Almost all of their missions succeed and provide valuable information and samples to improve our knowledge about the heavens, but even failures are worth a lot. They also have institutions in Switzerland to educate aspiring students and train astronomers. They have and always will headline the astronomical colors.